It's quite fun feeling to be guest in your own city, but let me give a try. So I moved to Berlin 2 years ago with an idea to get more experience working for bigger tech company, to get experience how it is when you are developing software for customers and in the market. And when I moved, I promised to everyone that I'm going to come back and tell the story, what did I do in those 2 years. So I'm keeping my promise, and I'm here basically to share some of the things that we do in Zalando. And to give you an insight, basically, who we are the company who wants to be starting point for fashion. And what does that mean is basically whenever you think about something that you want to buy or you want to get a look, you want to come to our platform and see what is the best for you. And yeah, this could be also a small app, but actually it's not. We are 5.4 billion euros company. We are in 17 countries. We have 15,000 employees. And more than 26 million of customers. And we are continuously growing. And when you think about technology, what does that mean? Is actually that we have around 2,000 people in tech on 7 locations. Our headquarters is in Berlin. But this all cannot give you like perfect picture of it until you see something like this. And this is like, we have 1,200 engineers contributing to one platform. And when I moved to Zalando, this is one of the first questions that people ask me, like, what those 1,200 people do on a daily basis. And in this talk, I'm going to share a story about what one of the teams who is in the middle of the platform do there. And I will start with explanation, what is checkout? What is the team that I'm leading? So what we want to try to do is to capture customers' intent to buy something. And how do you do that? By adding your item to shopping cart. So we own shopping cart for those 27 million customers. Then, of course, there is a part of login that is part of checkout flow, part of selecting your address. And just to give you an idea where complexity is coming from, you can get delivery to your home, you can get delivery to pack station, you can get delivery to some shop that is near your home, and this is just in Germany. Then, depending on the country, you have different ways where things could be delivered. And this is just address. Then you can select one of, I think, more than 20 payment methods, how you want to pay. Then you want to also to know when things are going to be delivered. I will also show you more examples, what can you do in checkout. And of course, we want to show you some success that, yeah, you managed to buy things successfully. How does that look like? And where exactly is the complexity? This is confirmed step when you are buying on Zalando. So basically, you come here and then you see many items. So first thing that you see is, well, you know, there is something that we call checkout flow. But checkout flow is probably a bit different per country. So you remember, 17 countries, let's say some complexity is coming from this. Then, of course, you have your shopping cart content. I will come back to this a bit later. Then, your billing address, your shipping address, different countries, different validation rules, a lot of stories behind that. Everything in one page. So if you think about teams owning microservices, they have their domain ownership, but here everything's like goes together. Here it must work. Then of course you see your payment method, you can enter your voucher or if you got a gift card. And we have something that we call Zalando Plus. This is our loyalty program. So you can subscribe, you can get some benefits. Of course, you know, what's the best place to use benefits? It's like when you decide to buy. And you can decide how fast you want your items to be delivered. Based on how fast your items are going to be delivered, it depends on how many parcels are you going to get this. And of course, we want to show you how much it's going to cost you. Some payment methods cost more, some payment methods are free in one country, you need to pay for them in another country. All in all, we have around 30 dependencies or 30 other teams that we are directly communicating with. Their microservices, their business domains, ending up here in checkout. Now, what is our mission? And what I said is like we are helping customers to go over the finish line. Basically, the most important thing in checkout is this orange button here which says place your order. No matter what happens, this must work. Because if this is not working, we are not earning money. And then let's talk about what exactly does that mean. And of course, you know, when you're working with 27 million of customers, first question that you ask, like, okay, can you scale? And when you ask, can you scale, you can ask question also, can you scale to what? And of course, one of the reasons why I moved to Berlin, experiencing something like this last Black Friday. In one day, we had more than 2 million orders. We acquired 220,000 customers in one day. Actually, the most exciting thing for every engineer is having those 4,200 orders per minute. To give you an idea what does that mean is we were all sitting in the office late night Friday evening looking into numbers. And then later, if you go to corporate.zalando.de, you can see what was the average order size during Black Friday, and it was around 60 euros. So 4,200 times 60, it's like 250,000 euros per minute. Now, could you imagine that this place order button is not working for 4 minutes? So this is 1 million euros. At the point of time where things must work smoothly. And of course, you can say, well, you know, this is your job, right? This is why you're hired, you have the team, you have everything what you need, so yeah, you deal with this. But then if you see some interesting things is, okay, let's take a look a year before. So year before, 1 million orders, 2,000 orders per minute. So within 1 year, let's say we have 200 teams. Let's say that each team just deploys 3 times per week. Nothing more, just simple continuous delivery. That comes easily to 30,000 deployments across the company within a year. I would assume that there is more, but let's just play with numbers. So this is what changed in 1 year. Apart from that, moving from AWS to Kubernetes and many other things. So this is not the same system. We need to support business growth. We need to support new services to our customers and at the same time achieve these numbers. And to make story a bit more interesting, this is just one example from Amazon what could go wrong. Well, you know, it could happen that there are no enough instances of some family type or something like this. So you need to plan. But you can also easily say, you know, it's you are in cloud, you have ways to deal with this. Buy capacity in front, plan up front, do load testing, all these things. But when the day comes, when it is like Black Friday, you need to be very creative. You need to make some decisions on that day. For example, what will happen if you need to do deployment and Amazon tells you there are no instances? There is no any more planning, there is no any more preparation. But let me walk you through the story a bit more, because availability is the problem that you solve with cloud provider. Let's talk about something else in checkout. So I told you, one thing that is important is that you as a customer buy. So let's talk a bit about reliability of our services. So let's start from shopping cart. If I would ask you what is absolutely needed from customer perspective that you enter checkout? Well, this is completely different question from coming up with business requirements and saying I need to have shopping cart which has price, selecting quantity, seeing a picture and all those things. But actually, all those things are nice to have when everything is working correctly. When you have highly distributed system and microservices, you don't know what of them is failing. So usually you have some article data store, usually you have some service that is providing you prices, but the question is, this is point of time when customer is still exploring. Do you really need to know all those information? And let's try to play a bit with this. Let's say that this is typical architecture. You have some service which has responsibility for shopping cart, you have another team owning articles, another team owning inventory, another team owning pricing, and you have some data store. In checkout team, we are using Cassandra, but you can have Postgres. It's not essential. So what could happen easily? Well, there is no data. Now, why this could happen? Well, if you have eventually consistent database, it could be just the data is not there. Or it could be network is down or whatever. So what can you do in this case? And let me give you, again, Black Friday example. Let's say that you are running tens of instances of car service and tens of instances of this data storage. So it's not anymore like one system connected to database and everything is working easily. And of course, easy idea is like you can retry. Let's say eventual consistency problem, you retry, data is there, everything is cool. But let's say that for some reason, one node is down. It could happen, again, nothing essential. So you drain connections, you say, okay, no more connections to this node, you recover it. And then let's say that you have hundreds of instances of this. What is going to happen? Each of them is having connection pool open. So you will have hundreds of network connections hitting this instance. And then you need to know what is going to happen with this. And actually, there is a quite good idea what can you do in this case. You just introduce exponential backoff. So you are retrying, but you are retrying, for example, first time after 200 milliseconds, then after 500 milliseconds, then after 1 second. So you are giving a bit of space and a bit of breadth to this service. And then you also can add some jitter. And you can say, okay, this is now some randomness that is helping us that we don't hit this instance. This is something, by the way, that we discovered during last Black Friday, that in Cassandra Driver 3.0, they don't have a jitter. We submitted pull request to, we submitted tickets to Cassandra, and actually they are going to implement this by starting from Cassandra 4.0. So how it happened that my team is actually contributing to open source? Because we had a need. But let's say that we solved problem with database. So we have retries, we are a bit more confident. Let's go to something else. What if you cannot get article data? And again, the question that you should always ask yourself, am I failing to my customer? Because your customers never care about your microservice architecture. Your customers never care about, is your technology 1,000 engineers or 2 engineers? Are you on Amazon? Are you on Google Cloud? They don't care. They want to come by and live. So, easy thing. Let's say that you have circuit breaker pattern, you open circuit. This service is failing, you don't want to kill it. You want to give them space to recover. But this is not solving problems to customers. This is still solving problem to your technology and your team. So you said, okay, there is no any more traffic to article service. You who are dealing with article service, please try your way to recover. What do you do for your customers? You can say, okay, we are introducing fallbacks. And then things become interesting. Are there any other service or any other team who can give you partial information or full information that you can show to your customer? Because, like I said, you don't want to fail. And then, for example, usually companies are having search. And then you can fall back to search. And then you get the data from search, and you know this is not the data that is maybe the latest, the most consistent, but you are also not at that point of customer journey where this information is the most important. So this is okay. And then the last thing that you can do, well, you can store article information in your data store, read it from there, and again, not fail to the customer. But let's make problem a bit more complex. Let's use typical, again, microservice setup and say, okay, car service is having some responsibility, but then for purpose of serving something on our front ends, mobile phones or web, we want to show customer delivery promise. Delivery promise is not responsibility of team or shopping cart service, but we need to serve this. So what is the best way? Well, you go to microservices.io and you see that you need to use API gateway. So you use API gateway and you say, okay, there is a delivery service providing this, show this to the customer. We know that customers want to know when they can get their delivery, so all cool. And then, well, what if this communication fails? So again, you are in the setup where one piece of information that could be relevant is completely irrelevant from customer continuing the journey. So you don't want to fail completely. So what we said, open circuit, try to retry, all these things are fine, but what else can you do? And then you see, okay, what we say is, okay, estimated delivery. Is there something that we know from our business model? And this is where communication and daily work between developers, product managers, and whole business becomes important. Because then you can ask them, okay, is there something that we know about our business? Well, we know that, if you are German customer, standard delivery is usually between 2 and 4 days, whatever. And then the question is, can we make this static? So, service is failing, and simple solution, put a file to S3 bucket, nothing else. And you solve the problem. For how long? This is the question that I'm going to answer later, and what can you do? But the main point is, are you building microservices that are customer-centric, and can you ignore or make that complexity much less complex? Then, of course, the question is, for how long do you want to show this? Because this could have an impact on business, and then you can come to all that story about lean analytics, metrics, and saying, okay, for how long this does make sense? But the first thing that you don't do is not fail to customers. Going back to Black Friday example. Basically, with all these reliability patterns, you enable your customers to go to the flow without them knowing what is happening in your technology. And dealing with those services at our scale, it's quite hard from the perspective that you know how those services operate. On another side, with the concept that we have where we say you build it, you run it, in your team you are fighting for capacity, which is new features, fixing bugs, operational work, all those like DevOps thingies that are now quite popular to do. So all those things are coming to one team that need to deal with them. So how are you going to make prioritization decision? So what are we trying to do? And this is something what we just, let's say, started in the team, is trying to define service level objectives for our services. So we start with error rate and we start with latency, and we say, okay, what if your service is failing 5 times? Are you going to stop feature that is bringing 50 million and try to fix that service? Or you are going to say, this is okay? This is not engineering decision. This is purely product decision. But you can work together on this. So you say, okay, what are the targets that we want to reach, or how do we want to serve our customers? If you have 0.1% of error rate, maybe it's okay. Again, depends on your product. But you define what is the threshold from which you start to act. How does it look like in practice? Well, just one of the services, internally developed tool, and we say, okay, it might happen that something is breaching, but basically everything looks okay. And then we have weekly operational review meetings where we get together all as a team, we analyze this, and we say, okay, maybe we are going to do something if there is indication that we want to do. If there is indication that something is wrong. But not necessarily based on opinion, or not necessarily based on, oh, I saw one problem, I'm going to jump on this. But there is another story about this, and this is, what if your service is breaching SLOs, and you have feature to do? Well, then you are going to prioritize this, because feature is going to potentially bring you value in the future, and your customers are suffering at the moment. And if you want to build customer-centric company and customer-centric mindset, then this is what matters today, and this is on what you act. And of course, doing all these things and being resilient and being highly available, this is all nice, but errors still happen. And one of the most amazing things that I experienced is joining Zalando is actually post-mortem culture. So I joined the company and we say, okay, we have blameless post-mortems. Now, being in checkout, you don't need much time to experience what does that mean. And if you are interested about some problems that we have, there is a person who is head of our developer productivity who is actually publishing our postmortems related to Kubernetes. And you can actually see one of the problems that we had. And we had one outage in our Kubernetes cluster in checkout, which was 20 minutes, which was 7-digit bug. And you can imagine being in the meeting with really top tech people in the company, where the only question that you need to answer is the data captured? So do you know what happened during that incident? What caused that incident, not who? And what are you going to do in the future to avoid this to happen again? Nobody was asking, is this your team? Why you didn't do this? Or why you didn't do that? It's about, okay, what did we learn? And what can we do from this? There is another evolution that we are actually implementing at the moment that I like even more. And this is what we say, when there is an incident, every team who can capture the learning should run their own postmortem. And this comes to quite amazing questions, for example, for us in checkout, that this is like, can we completely decouple ourselves from payments? Maybe there are ways, and now we are thinking about this, regardless of what is, or do we as a checkout need to be in Kubernetes? Or maybe it's not the best, but you can ask all those questions, you can run and you can go to the process in your team or within a bigger organization and learn from it. And this is all fine. Let's say that you'll learn, of course, with postmortem culture, you have whole company helping you, you are not alone. This is all great. But of course, you want new features. First of all, you want to give new services to your customers. Maybe you want to go to new markets. Maybe you want to deliver faster. Many other things. I told you, 30 teams, a lot of microservices. And then the question is how you build your software. Because you made it resilient, but I didn't tell anything about quality of your code base. It could be whatever you want, you will make it resilient. Put Kafka, put Istio, and it's going to work. And the thing that I would advise is maybe a bit of different what you would hear. And actually, I would advise people, oh, sorry, wrong slide. First question is, if you look at shopping cart, again, something that we own, is how would you model this? Why? Well, there is a clear responsibility of shopping cart. And one of the favorite topics usually at DDD conferences, everybody wants to model shopping cart. And you can say, okay, we are adding articles to shopping cart, right? We have quantity, but then things become interesting. We want to show you as a customer that there are some out of stock items. We want to tell you when things could be delivered. There is a difference, by the way, is there a partner item or not partner item? There is some delivery fee involved. And then the question is, again, you can build one service, put all the information there, and then what is going to happen when you need to change this? So how would you tackle and how would you approach the modeling? And my advice would be, even when you don't clearly know your business model or business domain, even if you cannot go to strategic domain-driven design patterns like defining a domain, defining subdomain, defining bounded context, you can start implementing tactical domain-driven design patterns. You can start with defining aggregate, defining entity, defining value objects, and moving behavior to your value objects. And this is something that we are trying to explore heavily in the team. And I will explain why now. I hope that you can see this. So let's say that we have quite typical code. You have shopping cart, some entity that is modeled, and you have some service which is just reading data from database, doing some kind of calculation, and then returning this shopping cart. So what you have here is what Martin Fowler calls dynamic domain model. You basically have like plain entity, nothing else. First thing that you can do is say, okay, let's move this calculate total to the cart and say, okay, cart as a domain object is going to own some behavior. So you don't need business requirement. You don't need ubiquitous language. You don't need anything of those like big domain-driven things. You just say, I'm moving behavior to my domain object. I'm making my domain object much smarter. Why? Well, around this, you build unit tests which are fast. You are testing business logic. You get correctness of behavior. And you don't need any big investment. You don't need end-to-end tests. You don't need integration tests. It just works. Of course, your service becoming thinner and probably not needed anymore, but this is another story. But when you start implementing this, so this is like really making domain objects to own domain logic, things could become interesting. Because then you can say, okay, let's see which items in my shopping cart are having inventory. And of course, okay, you say, okay, items with inventory, I'm taking a look into cart items, I'm filtering them, and all good. So another behavior, another set of unit tests, no need for big tests, fast feedback, you get correctness of the data. And then you can start thinking about, we are part of the company which is doing what? Well, we are selling articles. But then in cart, we call this cart items. So is this maybe article, and is item that is on stock actually sellable? And then you can start discussing this with product and going towards ubiquitous language without starting discussion from I want ubiquitous language from you. You can ask, okay, what are those items with inventory? Well, they are sellable articles. They have price, they have inventory, we can sell them. And then you can, of course, do refactoring, rename this, and say, okay, now these are like sellable items. Why would this be important? That's the question. Well, sellable article is implying specification. When you start using this language in your team, you know when you say sellable article has stock, has price, has who is selling the article, whatever. So by using the same terminology across different teams in the company, you get specification that is then built in your code. And you don't even have any more this misunderstanding between, oh, when you say sellable article, this means that, when you say cart item with inventory, when I go to another team, I'm going to tell them this is sellable article. Why is this important in our context? Using information, for example, about addresses coming from logistics. Using information about stock and prices is coming from platform. Using information about loyalty is coming from teams who are responsible for loyalty. If we start using always their domain language, we have a risk of polluting our code with something that we don't understand. If we don't use their domain language, then we always need to translate between us and them. So the question is, if you go and start doing domain modeling, you will need to answer those questions between your team and those teams and decide how you're going to make things less complex. You can introduce anti-corruption layer, or you can just say we are using their domain language because it also makes sense for us. But you are making informed decision. Another thing around deciding on domain language is also quite interesting. We as a one team are owning shopping cart and all other steps of checkout. So, shopping cart, beginning of the journey, okay, you are adding items, they could be out of stock. They couldn't be out of stock, you select how many items you want to have and all these things. And then you end up on confirm step. And on confirm step, you see your shopping cart, right? All good. But actually not, this is not shopping cart anymore. What you want to know is when you select delivery, this is going to be delivered in 2 parcels. Literally 2 packages. But your shopping cart doesn't know about packages. It's not their responsibility. So what we are talking about here, actually, this step is order. This is customer order. So from technical perspective, you can say we are solving problem easily. We have this cart service, we are just calling it here, we show the data, well, job done. But then the question is, when new feature comes, are you going to be able to support this? So being able to recognize where is this domain language, where it stops, where is your bounded context, is going to help you actually heavily with features in the future. Especially if you are consuming a lot of microservices which are having their own domain language. You need to decide. So even though if you are in one team, you really can have discussions around, is this really shopping cart? Or maybe this is not shopping cart anymore, and we need to model it differently. And if you start going in that direction, and if you start putting like domain in the middle, no matter what kind of legacy you have, no matter what kind of code you have at the moment, you can easily going towards hexagonal architecture. So you say, okay, we are putting our domain model in the middle. Well, now we can have discussion around what are domain services. So obviously, they should do something that your domain model cannot do. Then you can start having discussion around what are your application services and what are those other services coming from outside and how can you abstract them. And why would you like to have easy abstraction? Well, you don't know what those other teams are doing. They could be building new features, they could be having new requests, they might be building new services. They are going to come to you with an idea that they have new service at the point of time where you don't want them to have that idea because you're working on something more important. So your architecture needs to accommodate all these changes. So if you remember, we started from reliability and we said, okay, this must work, whatever you have. Then when you have this, we said, okay, let's try to identify what is our domain, what is our ubiquitous language. And then we can say, okay, maybe we can set up this architecture. Of course, if you can start this from beginning, go like this from beginning. This is like no-brainer. But usually companies move very fast and then systems are not very well defined at the beginning, but there is an easy way to come to this, or let's say easy enough way to come to this. And then things become more interesting. So you build it, you own it. We need to maintain our servers. We need to know how to maintain Cassandra. We need to know all those reliability patterns. We need to go towards DDD to refactor continuously, right? And we need to deliver new features. So the question is, how do we do this? And we have these 12 steps to project planning. So we do this checklist, and when we do that checklist, then everything is fine. Well, actually, it's not. So when I joined the team, team was doing 1 week iterations. And then it sounds from continuous delivery perfect, right? So you are continuously delivering software to production. You are continuously planning something, doing something. And they were doing story points. So first thing that I asked the team to do is like, okay, let's start measuring what we do. And we started measuring, we call this cycle time, some people call this lead time, but basically from the moment when feature enters work in progress until feature is delivered. And then you start learning something quite interesting. This is the real data from my team, actually quite recent, where we say, okay, we have something that we call product smalls. These are improvements on product. Could be changing translations, could be adding some tracking, could be fixing some small visual bugs. Then we have product development that is something bigger, something important for us or something important for whole company. And then we have operational work. Operational work is coming from this, you build it, you own it. So basically concept that you need to run your microservices. And then you start learning interesting things. Well, even though we want to plan that, operational work is 20%, in our team is, well, it depends from time to time. Why? When there is an incident, when you have 30 dependencies, if you want to run post-mortem, you usually need to contribute, you usually need to have action items. All these things take time. You're monitoring, you're alerting, updating libraries, dealing with technical debt. All of them are taking time. We are migrating to Kubernetes. This is also taking time, but when you start measuring, you start getting an idea what is happening in your team. So how do we plan our delivery at the moment is that we say, okay, we cannot just say we take 20 features, we implement 20 features. We need to do something else. This approach is not working. But on another side, the fact that we are measuring doesn't mean that we are getting predictability in the future. So be careful about causation and correlation. With this, you are just getting trend. You don't know, is it going to happen next time that there are 3 incidents and whole team is working just on this, or there are no incidents and suddenly you have capacity. So data should be used carefully. But we got some insights and we said, okay, transaction cost of delivering software, and this is all the meetings that you need, planning, grooming, retrospectives, is, well, quite stable. Batch size cost, basically cost of delivering feature, is something that we need to rethink. And then we said, okay, we are doing some kind of mix between Scrum and Kanban. We are planning with bi-weekly cadence of product features. Then we say we are planning some time for operational work and we're planning some time for uncertainty. But when it comes to product features, we all know that we cannot predict future, and data is telling that to us as well. So we say, okay, we are going to select always top 3 goals for every sprint, for every iteration that we do, so for every 2 weeks. And we know what are top 3 priorities that we want to achieve as a team. Everything else, we know that some things could go wrong and some uncertainty is going to happen. Doing this is helping us actually to always work on most important things. in the situation where you have a lot of communication, a lot of other teams approaching you, and all these things. And then we said, okay, by knowing all these things, let's try to create our definition of done. And when you are creating definition of done, at least this is my experience, usually people say, but we cannot ever implement this. So we decided to take a bit of different approach. We said, okay, let's try to create definition of done that is perfect. Let's imagine that we are living in a perfect world, and how would we want to deliver perfect software? To give you a few examples, well, documentation is something that everybody is avoiding to do. It's not up to date. We said, okay, our documentation is up to date when we finish the feature. Testing. How do you want to test software? You can decide on different testing strategies. How many end-to-end tests do you want to have? How many integration tests do you want to have? When do you want to do load tests? When do you write unit tests? We said, okay, our testing is going to be implemented for every feature according to our testing strategy. We said that for logging. Then we said, okay, for every feature we are going to implement alerts, checks, playbooks according to our guidelines in the team. So literally, we wanted to make perfect world. I will tell you now how we put this into practice. This is famously known as a Toyota Kata. And this is basically a way how to go from current state that you know how it is to some state which you set as ideal. So we say, okay, we completely understand our current condition. Or we can evaluate this. Our definition of done is our North Star, where we want to be. And then we are going to basically use continuous improvement event that exists in every agile approach, and this is called retrospective, to say, are we going to inspect and adapt now and say, where are we compared to the state where we want to be? And what we did with our definition of done is actually we said, let's evaluate this as a team and say, what are the practices that we do at the moment? So all of them are blue here. Blue things mean, okay, no discussion needed. This is something that we know how to do it. This is something that we did before. We just need to have good checks to do this. Orange things are things that we don't do at the moment. We are aware of them. So let's say, this is something that we did some time ago, but let's say code quality standards. Code quality standards is something that it also depends. We have Java, we have Scala, we have JavaScript. Code quality standards are different per language. We have some kind of agreements between team members, but they are not written. So we said, okay, maybe in next iteration, our goal is to define code quality standards. Can we make it smaller? Maybe we can define that only for Java services. Is it enough to use Sonar? Sonar, let's agree this in the team. But this is something that you decide as a team. And you implement one improvement in next iteration. And this is basically whole story. It's not about creating perfect delivery. It's not about creating perfect team. It's the same about implementing DDD practices. It's the same going towards SRE practices. It's about, do we know where we want to be, and what are we doing as a team to go there, to get there? And we are continuously evaluating and continuously inspecting where are we. And why do we do this? This could be the most interesting question. You have 27 million customers. They just want to come to your application, have the best experience, like select what they want to buy, get their favorite payment method, get their favorite delivery, and just get things delivered. Do you have microservices? Are you using Java, Scala? Are you in the AWS? This is something that they don't care. And this is what we are trying to abstract out. And if you have legacy code, this is fine. Because you want to put your customers at the first place. So I started my story by moving to Berlin and starting to be much closer to customer. And one of the feedbacks that I'm usually getting now from people from Serbia with whom I speak is that I stopped talking about technology. And in some cases, this is correct. And it's correct because Well, we put our customer satisfaction first. Yeah, that's the story.